Before we start today's video, I just want to make sure you guys check your answer for the first warm-up problem that you worked on. This was an IB question. It would be worth 4 marks if this was on a test. You want to make sure that you're stating the maximum value at -3, -54 as a coordinate, and a minimum value at x equals 3 at the point 3, 0. So make sure those coordinates are listed. Make sure your work is very similar to what you see in this video right now. And when you're ready, if you need to pause, feel free to do that, but when you're ready, we're going to continue on with the notes portion of this homework. So what we're going to be doing is previewing how we're going to be accessing derivatives in our next unit. So our next unit is all about using derivatives in real-world applications. So when you're ready, take a look at question number 1 and read it. We have the height in centimeters of a daffodil above the ground is given by the function, as you can see, as h of w, where W is the time in weeks after a plant has broken through the surface, and it shows its growth over its period of time for the life of the plant. So if I was just thinking about what this problem is asking me to do and what it's talking about is if I had a graph here, a plant starts at 0, 0, and from the time it starts growing to its maximum height to the time it starts decaying, we can model that using a parabola. So that's essentially what's going on here. And now I kind of want you guys thinking about the types of questions that we can be asked in a context of a problem like this. So some things that someone might ask us is, what is the maximum height, or when will the daffodil reach its maximum height? So we're talking all about the maximum at the very top of the graph. And it's kind of cool to make the connection between that and the warm-up we just did where we had to find the maximum. So it's kind of connected to a derivative, and we'll take a look at how. Another type of question that might be asked to us in a context problem like this is, how long might the lifespan of the plant be, right? So in that case, I'm looking at the distance between the zeros, and I would have to figure that out. So in the application problem, we're going to use derivatives to help us access and figure out information about it. When you're ready to take a look at the problem and what's actually asked of us, flip into the next page and we'll get going with that. Same problem, function representing the height of a daffodil as it's growing from where it starts from the beginning of the surface to where it grows and falls back down to the surface. So the first question is asking us to calculate the height of the daffodil after 2 weeks of time has passed. So remember, W is our interval of time. So when they're asking this question, they're really just saying, stick with the normal function for right now. After 2 weeks, what's the height? So what I'm going to be doing in the normal function is plugging in for h of 2. So I have h of 2 is equal to 24 times 2 minus 2.4 times 2 squared. And when you type that into your calculator, I can figure out that the height after 2 weeks for the daffodil is 38.4 centimeters. So always be aware of your units. The next part of the question is asking us to find the rate of growth. And you can see that they're using this representation notation of what we know a derivative to be, this dH/dW. So wherever you see derivative notation, kind of makes sense that they're calling this a rate in the context of this problem, because we know that derivatives are slopes, and slope is just a rate of change. So when they're asking us to find rate, you want to start transferring that knowledge of what you know of a rate to what you know about a derivative. So when I'm finding dH/dW, that really is the same thing as saying h prime of w. So I'm just going to take the derivative here to find the rate of the function. It's a nice one because it's just a plain polynomial. 24 minus 4.8 w. So far, so good. Now what they're going to ask us to do is, based on what we just found in the derivative, apply something to that. So in part 2 of this question, after the derivative was taken, they want to know what given that the rate of growth at W is 7.2 centimeters per week, they want us to find W. So let's rephrase that in our head a little bit. So given that the rate is 7.2, remember the rate was the derivative. So given that the derivative is 7.2, find W. Okay, so I'm going to be plugging in to this function and solving for W. So I'm going to solve 7.2. When they give that to me as dH/dW, sometimes it helps me write that down. So I know when I have this 7.2, I'm plugging it in for the derivative. So I get 7.2 equals 24 minus 4.8W. Feel free to pause the video at any time when you do this calculation through. If you want to try this one on your own, you should get 3.5 weeks. So that's part B. Part 3 of the question is now asking, when will the daffodil reach its maximum height, and what height will it reach? So if I want to know when the daffodil reaches its maximum height, this kind of goes back to the warm-up you started your homework with. If I want a maximum, I use the derivative to help me figure that out. The derivative gives me a critical value, and that critical value will help me evaluate and figure out where the maximum should be. So when they're asking when will the daffodil reach its maximum height, really what they're asking here is what's the critical value? So what that means is I'm going to take my derivative, the 24 minus 4.8W, and I'm going to set that equal to 0. When I set that equal to 0, I actually get a really nice value. I get W equals 5. So that answers the first part of the question. My maximum height will occur at 5 weeks. There is a follow-up to this question though, and they're asking what will the height be when it's at its maximum. So now that I know it's going to take 5 weeks to reach my maximum point, now I want to figure out what the value is, and in a case like that, if I want to evaluate what I got from the derivative and get the output for my rate using the derivative function, I'm going to plug back into the original now. So now I'm going to plug back into H. I'll get H of 5, and when I do that calculation and plug in very carefully, you should be getting 60 centimeters. So again, feel free to pause the video, make sure you're getting that value when you plug into your original function to get the maximum height. We're almost there. There's one more part of the question that they're asking us, and they're saying once the daffodil has reached its maximum height, it begins to fall back towards the ground. Show that it will touch the ground after 70 days. So this one's a little tricky because it's to show that, so that does require us to do a little bit more work than we are used to doing. But the other thing is they're starting to talk about 70 days, which if you remember our unit of time where we started was in weeks. So 70 days I have to convert to weeks first, so there's 7 days to a week. So I know 70 days is really 10 weeks. So you want to do that conversion and address that first if you ever see an instance like that. So now I'm going to go back to the original. So I know that it's going to touch the ground after 10 weeks, and I want to show that the height will be back to 0. So I'm going to set my original function, 24W minus 2.4W squared, equal to 0. And if I want to show that this is true, I'm going to plug in 10 for my W's, and hopefully it's going to equal out to 0 when I'm done. So I'm going to see if 0 is equal to 24 times 10 minus 2.4 times 10 squared. You don't want to cut corners in any show that problem, so let's keep working this arithmetic through. So 24 times 10 is 240. Minus 2.4 times 10 squared. Type that into your calculator if you're not sure, but that's 240. 240 minus 240 is 0. So we just showed that after 10 weeks, we're going to go back down to the ground at a height of 0 centimeters. That's all we needed to do for that. So feel free to watch this portion of the video at any more times that you need to. You could pause, replay, any part. The next question is one that we're going to be interested in looking at in class on Monday. So you want to try this one on your own. You should have more work than what you see on my answer right now. So when you pause the video and try this one on your own, please make sure that you show a little bit more work so that you understand all the moving parts of these problems. I'll put the answers up for you right now, so when the video ends, you could pause it at the very end to make sure that you have all the correct answers. Feel free again to watch this video, make sure the assignment's done and checked, and we'll see you again in class next time we see you.